Hi everyone, welcome back to Mind and Maths with Amina. In today's video, I'm going to solve key activities and exam style questions step by step, keeping each part short and easy to follow. This is chapter 2 and it's called Basics, and it's in the Mathematics 1 study guide, which is provided by University of London for their EMFSS courses. Okay, so let's begin. The first activity given in the subject guide is that the value of x1 is equals to a 3 and the value of x2 is given as 1. The value of x3 is given as a 4 and the value of x4 is a 6. So the first thing that they want us to calculate is the summation. This sign is the summation sign, and it says they want the sum of values from 1 till the 4th of xi. So I is in the subscript, and this is the value that's going from 1 till 4. And it's a summation sign, so we basically have x1 plus x2 plus x3 plus x4, and therefore we have a 3 plus a 1 plus a 4 plus a 4 plus a 6. So that's a 6 plus 4 is a 10, and then we have a 14. Okay, the second thing that they want us to find is this sign basically denotes the product of between terms. So the product, they want us to find the product of the terms from the first term till the fourth. So we want to multiply x1 to x2 to x3 to x4. So this time we're looking for 3 multiplied by 1 multiplied by 4 multiplied by 6. So 6 4s are 24, and 24 multiplied by 3 is a 72. So we can write it like that. So we're done with the first activity. Okay, the next activity, it is asking you to expand. Okay, so expansion means that first you're going to multiply x squared with this, and then you're going to multiply the second term, which is a minus 1, with x plus 2 again. And now we can open this up. It's going to be an x cube plus 2x squared minus an x minus a 2. And it cannot be further simplified. Another way of solving this is that you can basically write this down like this, and just imagine that you first have to multiply x squared with an x, and then x squared with a 2, and then comes the turn of the next variable, minus 1 with an x and minus 1 with a 2. So I think this is quicker, because then I'll be like, I'm multiplying x squared by an x, so it's simply an x cube. Then we have a 2x squared, then minus 1 to an x, it's a minus x, and minus 1 into a plus 2 is a minus 2. So we can even do this directly if we like. Oops, sorry. Just trying to sit in a cozier position. Okay, let's continue the third activity. The third activity tells us that there are two sets. The set A contains the elements 1, 2, 3, and 5, and the set B contains the elements 2, 4, 5, and 7. So they want you to tell us, they want you to find the intersection of A and B. So basically we're looking for elements which are common in both. We can see they have 2 in common, and a 5 in common. And if they had asked for a union is all the elements in both. So that would be a 1 and a 2 and a 3 and a 4 and a 5 and a 7. Let me check. 1, 2, 3, 5, 4 comes from here, and there's a 5 here as well, and 7. Okay, good enough. Remember, the intersection is associated with the word and. So the element has to be in A and it has to be in the set B. And the union is associated with the word or. So which means that the element has to either be in A or it could be in B. So visually, we can also show these using a Venn diagram, which helps us see these what do you call them, these sets more easily. Okay, wait, I need my iPad to cooperate with me with this one. Okay, so if this is set A and this is set B and the whole thing is this universal set A, set B, and this is the universal set. So when we're talking about A intersection B, it is all these elements that are in both. And they have to be in A and B at the same time. And when we're talking about the union, it can be in either, and it can even be in both. So it's basically all of this. Okay, moving forward, let's do the next activity. The next activity in the subject guide is giving us a linear line, and it wants us to find the formula for the inverse. As a recap, the inverse of a function, suppose this is a function and this is my x value, this is my fx. So basically this is my domain and that is my codomain. So when I have an input and I put it in the function, it gives me an output. So I'm going from this direction, I'm taking the input, function f takes the input and gives me the output. What the inverse does, it takes me in the opposite direction. So basically it takes the image and gives me the pre-image. So it basically just takes me backward. I'll repeat. The function takes a pre-image and throws back an image, while the inverse takes the image and brings me back to the pre-image. Okay, so let's find this. When we are asked for the inverse, I say fx is equals to 3x plus 2. And as a step 1, just make x the subject. There are a lot of students who enter this program who don't have, who hadn't taken mathematics in their A levels, and therefore I am teaching in a way that I'm assuming that you haven't had exposure to mathematics in your A levels. Okay, so y is equals to 3x plus 2, and I want to make x the subject, so we get a 3x, y minus a 2, and then we have a x is equals to y minus 2 over a 3. So what this shows is that the inverse function, if I put in a value y like this, it's going to return, it's going to give me a value x. Okay, so this is basically my inverse function. So I put in a value x here and it gave me a value y, and now I'm putting in a value y, and it's going to give me some x. So this is known as the inverse function. And conventionally, since we can use any letter to denote this, conventionally the inverse is written conventionally and rather annoyingly. It's written like this, the inverse function using x. However, even if you leave the answer like this, you're still going to get full marks. So the first step could be that you make x the subject, and the second step is just to state the inverse function. And if you want to further make another step, you can just say replace x with a y. So if you want another step, that an additional step from here could be replace y with an x. Okay, moving on to the next activity. It says if the function is equals to an under root of x and another function g is equals to x squared plus 1, they want us to find the composition fg. So basically, which means that you put the function gx as the input to the function f. So they want us to put the function gx into f. So what is that going to be? Remember, any value I put here, the function is going to give me the under root of that value. So now that I've put this number here, it's just going to give me the under root of this number. So I just get the under root of this number. Even though this activity hasn't really asked us, but let's find the composition of G and F, and let's just show that composition is actually not commutative. So if I put in the function fx into gx, that would mean that I want to substitute an under root x into the function, and that means wherever I see an x, I'm going to put an under root of x. So if I put an under root of x and then it has a whole square plus a 1, so we are left with x plus 1. As you can see, both these answers are not the same. So the composition of fg is not the same as gf. So function composition is not commutative. Okay, moving on to the next activity. Okay, so this activity is asking us to sketch these curves. Okay, the first thing that we want to notice is that these are actually linear lines. The good thing about linear lines is that you only need to do one step, which is to find the intercepts. And basically, if we want to make it abbreviate, expand on this, we just need to find the y-intercept, that is all values where x is equals to 0, and we then want to find the x-intercept, and that is exactly where y is equals to 0. If suppose they give you a question in which the line is not linear, so you could have a quadratic curve, or even maybe a polynomial of a higher order, for instance, of order 3, order 4, whatever. And the first step is always to find both the intercepts, the y and the x intercepts. The second thing that you need to find is that you need to find the critical points. These are sometimes called the turning point. It's also in many texts called the vertex. So you have to find the critical point. And the third thing is that you have to classify these minimum points, minimum maximum points. So you have to classify the critical points as either being a maximum or minimum. And the final step is to see limiting behavior. And don't worry about these. I'm sure your teacher has, you must be studying either privately or in a candidate center. So if you are studying in a candidate center, your teacher will actually show you all of these steps. And and don't worry, we are going to actually solve questions. So even if it's not covered in your class, we'll still be solving questions here. Okay, and these concepts will get clear. Okay, so let's do the first curve. The first is y is equals to x plus 3. So whenever x is equals to 0, y is going to be equals to a 3. So I have one intercept here. And whenever y is equals to a 0, x is equals to a minus 3. So we have another intercept here, a minus 3 and 0. And that's all I need to draw a straight line. Okay, the next is y is equals to minus 3x minus 2. Okay, y is equals to minus 3x minus 2. Okay, so when x is equals to a 0, y is equals to a minus 2. So this is one intercept. And whenever y is equals to a 0, x is going to be a minus 2 by 3. So that should be 0.3. Let's just leave it in a fraction. Okay. So next, what you have to do is just sketch this. Since we're not expected to draw it in scale, but we can still like try to use a ruler and just draw it in a way that it is almost drawn to scale. Okay, a minus, let's make it bigger then. Okay, so 1. Okay, 1 and a 2 and a 3. This looks nice. And we can extend this also. And a minus 1, a minus 2, a minus 3. Okay, and on this side, a minus 1, a minus 2, and a minus 3. Okay. So plotting these points, the first point was a 0, 3. So right here, a 0, 3. And a minus 3, 0. Oh, actually, I got it wrong. 0, 3 is over here, 0, 3. And then a minus 3 and 0. Okay, here we go. Excuse me. I haven't been able to recover from this flu since a month. Okay, so this is my line for x plus 3. I think it was x plus 3. Yeah. Okay, what about the next one? We have when x is equals to 0, y is equals to a minus 2. So over here. And then x is equals to a minus 2 or somewhere over here. So these are the two intercepts in this. Yep. Oh no. Let me try to fix that. Okay, that was quick. And the equation of this line, so conventionally it's nice to write the equation very closer to the line that you've drawn it. And we can see that this also has like this there's a point of intersection. So if I had drawn this on a graph paper, I would have actually gotten a pretty nice an exact position, exact point of intersection. But because this isn't drawn to scale, so the only way to find this point is to solve these two equations simultaneously. So you have to solve simultaneously to obtain this point. Okay, moving on. I don't want any class to go beyond 30 minutes. Sketch this curve. Where does it cross the x-axis? Now you can see this is actually it's a polynomial of degree 2. Polynomial of degree 2. What this means is that the maximum number of times it can cut the x-axis is 2. So for instance, we could have a scenario like this, or a scenario like this. So it's just cutting it once, cutting it twice, or we could have a scenario where it's not cutting the x-axis at all. So the maximum time it can cross the x-axis is going to be the degree that the polynomial has. So in this case it was 2. So the highest number of times it can cross the x-axis is 2 times. Okay, so now let's sketch it. Remember, we want to find the intercepts. So the y-intercept is the quickest because that is where the value of x is equal to 0. So 0 square plus 4 0 plus 3 is simply a 3. Therefore, the first point is a 0 and 3. Okay, next, the x-intercept. The x-intercept is where y is equals to 0. So that would give me this equation. At this point, I could solve this in a number of ways. What I can do is that I can use the formula which is minus b plus minus b square minus 4ac over 2a, which is actually derived from the completing square method. So another option is that you do the completing square. And the third option for us is to simply factorize. In this scenario, I can see that both of these have a positive sign, and I know that 3 ones are 3, and if I add 3 and 1, I'm going to get a 4. So in this scenario, it's quite easy to just factorize. So I can write the 4x as a 3x plus x, and then I'm just going to look at this expression and then look at this expression. If I take x out as common, I'm going to be left with x plus 3 over here. I've been focusing on this one, and for that one I'm just going to get a 1 x plus 3. If I take x plus 3 common from the first expression, I have an x, and from the second I have a 1, and there you have it. We have a solution. Either 3x plus 3 is going to be a 0, or x plus 1 is going to be a 0. So therefore x minus 3, x is equals to minus 1. Hence we have these intercepts, minus 3 and 0, and minus 1 and 0. Okay. It actually did tell us to sketch it. So let's sketch it. Or maybe like this time, just for fun's sake, let's use a graph paper. Okay. We have minus 1, 3, and okay. the numbers aren't that big, so we can leave a lot of space. Okay, this looks nice enough. Let's take this as a 1, 2, 3. 1 minus 1 minus 2 minus 3. Okay. A 1 and a 2 and a 3. Oh, yeah, sorry. Minus 1 minus 2 minus 3. Okay, so firstly the intercept is a 0 and 3. So we have 1 point here. And then we have minus 3, 0. So minus 3, 0. And another point, minus 1, 0. Okay. Now we need to find the critical point as well. Let's do the completing square because at this point, this is the first chapter, taking the derivative is not taught in this chapter. It will be taught in the next chapter. So in the best way to find the critical point is to take the derivative. But in this chapter, they haven't introduced that. So let's just do the completing the square method. We have y is equals to x square plus 4x plus a 3. A 4 divided by a 2 is a 2. So that gives us our hint that I have to add a 2 square and subtract a 2 square. Okay, this expression is simply a plus b square is equals to a square plus 2ab plus b square. Okay, so we can use this fact to write this expression as x plus 2 square. Okay, and then we have a minus 4 plus a 3. So we have an x plus 2 square and minus 1. Okay, so this form basically tells us the vertex is equals to minus 2 and minus 1. And since the value of this variable 1 is greater than 0, therefore we have a minimum point. I think for those who actually are not familiar with this, I'll just write this generically for just in case if somebody's unfamiliar. If we have an a minus b square plus suppose c, then if a is greater than 0, we're going to claim it to be a minimum point. If a is less than 0, then it's a maximum point, and the vertex is going to be b and c. Okay, I'm sorry if this was boring for some people who already know this, but I didn't want to take a chance for just in case somebody was unfamiliar with this. What am I doing? Sometimes technology frustrates me. Okay, so let's do this. We had a vertex of minus 2 and minus 1. So we have a minus 2 and here we go. Minus 2 and minus 1. So let's draw our curve. It should go like this and then up. No. It needs to be prettier than that. Okay, I think I'm gonna try to, yeah, baby, this looks nice. Yay. And we're done. And conventionally, we should write the equation of the curve right next to it. So it should be, I want to label this line with that. Okay. I'm not sure how much time has elapsed. I think there was another activity. It's simply factorize. Ooh, find the points of. Maybe I should do these in the next class then. Or perhaps, actually, it's just YouTube. You can pause the video and just resume later. So let's just finish the activities. This question is asking us to factorize. I'm just going to speed up. If I take x out as common, I'm going to get a x squared plus 4x plus a 3. Oh, we just actually factorized this a while ago. Yeah, isn't that the same? Yeah, it is. The roots were x plus 3, x plus 1, x plus 3, x plus 1. Wow, that was fast. Yay. This is factorized, and the last activity in this chapter, it's asking us to find the point of intersection. Okay, when you want to find the point of intersection, it's going to be very inefficient if you plot this. Just solve it simultaneously. So y is equals to 2x minus 3 is your first equation, and y is equals to x minus x over 2 is your second equation. Just simply put 1 into 2 to obtain the answer for x. Let's do it. I'll get a 2x minus 3 is equals to 2 minus x over 2, and therefore I have a 5 over 2x. 5 over 2x is equals to a 5, and hence 5 and 5 cancel out. I'll get an x is equals to a 2. So that's the x value of my intercept. Now I need to find the y, a corresponding y value. I'm just going to substitute. Since it's a point of intersection, you can put it in any line that you like. So I'll get a 4 minus 3, so this is a 1. So our point of intersection is a 2 and 1. So yeah, I think I managed to keep this in hopefully less than 30 minutes. And in part 2 of this series, I'll just continue solving the activities and the sample examination questions given in the EMFSS study guide. Take care for now, be kind to yourself, and treat others the same way. Take care.